everybody, welcome to Cambridge Guru once again. We've already started our new chapter vectors, and in the last video we introduced the concept of vectors. Since vectors is a physical quantity, so we are not dealing with the physics concept or physics aspect of vectors. We are dealing with only the mathematical aspect, and in that we introduced the concept of a vector, that it is a physical quantity which is having both magnitude and direction. And then I introduced the concept of unit vectors along x and y direction. So the last video was about dealing the vectors in two-dimensional plane, in which the unit vectors were just I and j along the x and y axis respectively. Then we did a couple of questions to convert a vector into r and theta form, and vice versa, from r and theta form, how to find out the vectors or write the vectors in component form. Component form means with ai plus something bj, or xi cap plus yj cap, something like that. Okay. And we also introduce the concept of position vectors, right? So just like we have a point in a two-dimensional plane, similarly we have a position of a vector which is called the position vector. Means it is just that joining the point with the origin you will get a vector, and that will be your position vector. Okay, so for example, if any point is having coordinates, let us say 1, 2, so we have a position vector OP. If I call the point as P, which can be given by a position vector which is I cap plus 2 j cap. Since x coordinate was 1, so component along the x-axis is just 1, so I will write this as 1 into I cap plus 2 j cap, right, because the y coordinate was 2. So extending this concept to 3 dimension, we have the new topic for this class is vectors in 3 dimension, and the unit vector which is along the third direction, which is the z direction, is denoted by k cap. Okay, so now we can represent any point in a 3-dimensional plane using a vector. So position vector will be of the type xi cap plus yj cap plus zk cap. Okay, so if a point is 3, 4, 1, so we can define the position vector of that point by OP, right, which can be given like 3i cap plus 4j cap plus 1 into k cap, which is just k cap. This is the component form, and this we can write in vector form also, means using a column matrix. Okay, so this is the position vector. This we have already talked about, and it says that the line which joins the origin to the point 3, 4, 1 is the position vector. Okay, so if we bring our x, y and z Cartesian system into the vectors definition, so if we have a point in a 3-dimensional plane, that point may have a position vector which you will get by joining the origin to this point. Simple, you will get a direction. Okay, so that position vector can be written in this column matrix, which is 3, 4 and 1, or in the component form as 3i plus 4j plus single k cap, 1 k cap. Okay, so for example, let this illustration says that the points L, M and N, they have a coordinates of 4, 3, minus 2, minus 1 and 2, 2 respectively. We have to write down in component form the position vector of L and vector Mn. So if it says the position vector of L, okay, that is denoted by always the position of this final point, which is L with respect to origin, and we write this vector as OL. Whenever we have to define a vector, be it a position vector or any vector, what we will do is we will subtract the coordinates of this first point from the second point. Please remember this. Okay, this I can write as the subtracting coordinates of second point in the sense this second letter, okay, this L, whatever the coordinates of L, second point from It is just reverse of this. Let me correct this. Subtracting the coordinates of first point from the second. Okay, final minus initial. Coordinates of first point from second one. That is final point minus initial point. Okay, so here since the final points coordinates of point L are 4 comma 3 and this is origin, so origin coordinates are 0 comma 0, and as you know that y coordinate will be subtracted from y only and x with x, so 4 minus 0 is 4, 3 minus 0 is 3, so position vector is denoted by OL, whose coordinates, or in the component form we have to write, that will be just 4 I cap plus 3 j cap. Okay, then we have to write the vector mn. Okay, this first part we are doing. So vector mn, as I said, that if you have to write any vector in component form, just subtract the coordinates of final minus initial. Okay, that means mn can be written as position vector of on minus position vector of om. Okay, so on means coordinates of n, which are 2 comma 2, minus om means minus 2 comma minus 1. Okay, it is easier to write this in column form like this, 2 2 like this, minus 2 comma minus 1. Algebra, dealing with algebra, it becomes, or it seems to be, it looks easier. So 2 minus or minus 2 is plus 4 and 2 minus or minus 1 is 3, right? So this is the position vector or the vector mn, not the position vector. If I am talking about position vector, then I will say that position vector of n with respect to m. Okay, if I have to call this vector as a position vector, so this 4 comma 3 is the position vector of n with respect to m. Okay, otherwise you simply call this as just vector mn. Okay, so normally what is the norm is that position, when we are talking about position vector, so it simply says the position of a point with respect to origin. Okay, so second part, it says what do your answer to part 1 tell you about the lines OL and MN. OL and MN. So as you can see that the position vector of OL, if I have to write this in column form, can be written as 4 and 3. Okay, this is the component form and this is the vector form or the matrix form, 4 and 3, and again Mn is also 4 by 3. So I can say that vectors OL and Mn, they are parallel. Okay, what is the condition for parallelism, right? Or if two vectors or two lines are parallel, that one vector is a scalar multiple of other vector. Okay, so this OL and MN, these are both equal vectors. Basically, these are not just the parallel vectors, but they are also equal. Okay, because x coordinate is x and both x and y coordinates are same. Okay, next we have to write in component form the vectors represented by the line segments joining the following points. Okay, so this 2 comma 3 is a point. Let us say this is the point 2 comma 3. I'm calling this point as A, and the second point is B, which is 4 comma 1, right? So this vector we have to find out in component form. We have to write, so I am calling this as vector AB, so it will be position vector of OB minus position vector of OA, B minus A. So 1 minus 3 is minus 2. Sorry, first we have to write the x coordinate. So 4 minus 2 is 2. Component form we have to write, so 2 I cap minus 1 minus 3 is minus 2. So it is plus 2 j cap. Okay. 4 minus 2, 2, 1 minus 2, no, it will be negative, sorry. 2y minus, just we have to write 4 minus 2 and 1 minus 3. Okay, this subtraction is inherent in this. So do not use this negative sign twice. Since there is a negative sign, means you are just subtracting the first coordinate from the second. 4 minus 2 is 2, 1 minus 3 is minus 2. So minus 2 j cap. This is the first part. And similarly, you can do the second part. 6 minus 4 is 2i cap and 0 minus 0 is just 0. So it is just 2i cap. Okay, and if you have to plot this, the second point, that why it is or how this vector will look like, that since 4 comma 0 is a point on the x-axis with coordinate 4 comma 0 and this is 6 comma 0 again on the x-axis. So what you're talking about is the vector which is lying along the x-axis like this. Okay, this is just 2i cap. Next is again the points A, B and C have coordinates 2, 3, 0, 4 and like this. We have to write down the position vectors of A and C. So position vector of A are 2 comma 3. For C is minus 2 comma 1. So it is just 2 comma 3 or 2 by 3. Not by, just write 2 and 3 and minus 2 and 1. Okay, this is OA and this is OC. Please remember to write the position vector as OA and OC. Do not write A and C. Introduce this origin in the vector notation. Second is write down the vectors of the line segments joining AB and CB. So AB is basically what? It is OB minus OA, subtracting the coordinates of A from B. So this is A and B is 0 comma 4. That means 0 minus 2 is minus 2. And 4 minus 3 is 1. So minus 2 and 1 is AB and CB is again, not again, it is OB minus OC, subtracting the C coordinate from B. So this is B, this is C. 0 minus or minus 2 is 2 and 4 minus 1 is 3. Okay, this is your CB. All right. This is your second part. Third is, what do your answers to part 1 and 2 tell you about AB and OC? So this is AB, which is minus 2 and 1. OC is minus 2 and 1, as you can see here. Okay, this is your OC minus 2 and 1 and this is AB minus 2 and 1. So again, these two line segments or these two vectors, these are parallel vectors or equal vectors, I would say. Not just parallel, they are equal vectors. Okay, because values are same. They are not just the multiple of this. Values are same. Okay, and CB and OA. So if you compare CE, which is 2, 3, and OA, initially the first point is again 2, 3. So OA and CB are equal and OC and CB are equal. So if these four vectors are equal, there must be a quadrilateral which is forming. So we have to describe the quadrilateral OABC. What kind of quadrilateral is this? Okay, so let us plot these. Not the plot, but let us have a rough sketch. So this is our origin. O, there is a point A. This is vector OA, right? Then we have in a cyclic manner OA, there should be a point B. So let us say B is here. And this is your vector AB. Now as it says that this OA is equal to CB, right? So this is B, so this point must be C. The third point, or basically the first point if you're calling as the origin, this is second, this third, then fourth point, which is C, it must be lying somewhere here to make this OA and AB as equal. Means the opposite sides of this parallel, not the parallelogram, but the quadrilateral are equal. Okay, so I'm just let me have the rough idea. Okay, like this. Okay, CB. And lastly, we have OC, as AB and OC are equal. So this is AB and this is OC. please mind the direction. As the name is given that AB and OC must be equal, so this is AB in this direction, in the positive y you can say, so OC should also be in the same direction. If you're taking the cyclic order, that first vector is OA, then this AB, then BC, then you will get a negative in this vector. But according to the question, vectors OC and AB are equal, so their direction must also be same. Okay, if one vector is the negative of another vector, okay, this is also important, that if there is a vector A in this direction and there is a vector B but in the opposite direction, and it says that vector A is equal to minus B, negative of another vector. Okay, so if this is A, then I can write this as minus A. That size magnitude is different, is same, but the direction are opposite. So minus sign is just indicating that. Right, so what kind of quadrilateral is this? Since opposite sides are equal, so I would say that this is a parallelogram, right? And since adjacent sides are not equal, right, vector AB and BC, these are not equal. If you compare AB vector, which is minus 2 and 1, this is your AB vector, and adjacent vector is OA, which is 2 comma 3. So AB is not equal to 2 comma 3 or OA. So adjacent sides are not equal, but only opposite sides are equal. So I will say that this is a parallelogram. Okay. All right, fine.